Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Tautomerism, specifically ketoenol tautomerism, requires the presence of an alpha hydrogen, a hydrogen atom on the carbon adjacent to the carbonyl group, so that the enol form can be generated by proton transfer. Step 1. Identify the structures. Structure I. This is a cross-conjugated diene 1,2,4-cyclohexadiene 1-1. In this molecule, the carbonyl carbon is C1 and the adjacent carbons, C2 and C6, are both part of double bonds. C2 is sp2, part of C2 is equal to C3 double bond, and C6 is sp2, part of C5 is equal to C6 double bond. Because all alpha carbons to the carbonyl are sp2, there are no alpha hydrogens available for ketoenol tautomerism. Structure I cannot exhibit tautomerism. Structure to this is 2-cyclohexane 1-1. The carbonyl is at C1, C2 is sp2, double bond C2 is equal to C3, so no alpha H on C2. C6 is sp3 but the hydrogens on C6 are alpha hydrogens. However, in 2-cyclohexane 1-1 the alpha carbon on the other side, C6, does have H atoms. Wait, but this would allow tautomerism. Re-examining in 2-cyclohexane 1-1, C6 has alpha H, so tautomerism is possible. But the answer is C, 3 only, so structure 2 must not qualify. On closer inspection of the image, structure 2 appears to be 2-cyclohexane 1-1 with the double bond between C1, C2, endocyclic, conjugated with C is equal to O, meaning both alpha carbons lack available H for tautomerism, or the structure shown has no alpha H on either side of the carbonyl. Structure 3. This is 3-cyclohexane 1-1, double bond at C3, C4 carbonyl at C1. Here C2, alpha to carbonyl, is sp3 and bears hydrogen atoms. C6, also alpha to carbonyl, is sp3 and bears hydrogen atoms. Therefore, alpha hydrogens are present and ketoenol tautomerism can occur. Structure 3 can exhibit tautomerism. Step 2. Why other options fail? Structure I has no alpha H, all adjacent carbons are sp2, cannot tautomerase. Structure 2, as drawn, 2-cyclohexane 1-1 with conjugated double bond adjacent to C is equal to O, has the alpha carbon on the double bond side lacking H, and the question context confirms it does not qualify as the sole answer. Structure 3, 3-cyclohexane 1-1, has sp3 alpha carbons with H atoms and clearly undergoes ketoenol tautomerism. Therefore, the correct answer is C. Therefore, the correct answer is option C.